I first learned about you guys, I think it was about 3 years ago at Camex.
Mm-hmm.
I had a friend comes up to me and he says, "Man, you got to talk to these guys. I mean, this is amazing," because he'd gone by your booth, and it was a really new technology at the time. I'd never like seen this technology, so immediately had you on, and you know, it's amazing looking at your growth and what's happening. Just even over the last few years, I know that you guys have had a lot of success, and you can kind of fill us in on some of the updates here.
Yeah, absolutely. No, thank you. It's always, we like talking about surfaces, right?
Yeah.
And surface chemistry and how they actually really relate to how you're making stuff every day, right? I mean, the thing is that, there's a lot of things about, I'll just say, building anything that are well understood, but in so many kind of corners of material science, when you get into actually putting, chemistry A onto surface B, there's not great generalized understanding around what is happening there. And because we don't have that understanding, it means we actually lack a lot of control in production.
Yeah.
And that means we get randomized failure, or we're not as efficient as we could be, right? Or we're slower to develop something new, right? Because we don't have that confidence. And so, our goal as a business is to, one, help provide that knowledge, and then two, help provide that control in the factory, right? Through tools. And so it's a fun place to be because you're always learning, you're always teaching, you're always solving problems. I think nothing gets the team, like our team, more pumped up than when we get a client that calls us and says, "Oh man, you won't believe what we just found out with one of your devices. Like, you won't believe what we found in the bonding shop. Like, oh my, we're using contaminated sandpaper. We've been doing this for 20 years. Oh my gosh." I mean, just stuff like that. It's just, we always get a kick out of that. It's fun.
Yeah. So before we get into it, for listeners who may not be as familiar, if you would give us maybe a 60-second highlight of Brighton Science, the technology, what exactly you all do, and how you go about analyzing surface readiness, whether it's for a bonding application, a release application. Just give us a highlight to begin with.
Yeah, absolutely. So Brighton Science, really, we're based out of Cincinnati, Ohio. We really exist to do one thing, and that is to prevent part failure in manufacturing related to, cleaning, surface prep, adhesion, release, molding, brazing. I mean, any of these processes where you're actually bringing materials together and there's a chemical reaction happening. All right. And we're really doing that in two ways. We've got a full materials lab that does consulting. Think process development, like choosing how to prep something or looking at plasma or whatever it is we're going to do. The lab also does a lot of root cause analysis and corrective action. So a lot of problem solving, right? In addition to that, we've developed a proprietary measurement platform of handheld and inline instruments that allow a technician or an engineer or a QC professional to walk out onto the floor and on real parts get surface chemistry information about how well prepared a surface is day to day, shift to shift, part to part, operator to operator. So this kind of unique combination of the laboratory plus our proprietary inspection tools means like we can control the third key input to success, which those three inputs are the chemistry of what you're putting on the surface, the way you're putting it on the surface, heat, fixturing, cure time, in the case of bonding, bond line thickness, and then the surface you're putting it onto.
Right.
And typically manufacturers do 1 and 2 really well, but they don't have any objective data on number 3. And so we're providing that information.
Right. Yeah, because I mean, so just because the surface looks clean, it looks prepared, doesn't mean it's chemically prepared for bonding.
Yeah, not at all, man. I mean, kind of the old way of determining if something was especially in composites, well prepped or not, is a visual check. You're just looking at it and saying like, hey, does it look like it was scuff sanded? Right? Or do I see any contamination on there? And the thing is that bonding or release is happening at the top 200 molecular layers of a surface. So what that means is you can have two surfaces that look identical. You can have two surfaces that were both scuff sanded, and one's going to bond great and one's not.
Yeah.
Right. And so you got to have tools and understanding of what's going on at this really thin region that's invisible to the naked eye. So our goal is to make the invisible visible. right? Put some information, put some data to
Yeah.
what we're producing out there.
We always laugh at, and coming from a background, because I have a background in release technology, so it's always funny to, because you have this conversation with a technology company like you, and it's like, a lot of industries in the, specifically in composite, a lot of companies are still doing like tape tests, where they put the,
Yep.
this. I mean, it's like,
qualitative.
in
Yeah, it's like a
2026.
qualitative. It's literally a touchy feely test. It's like, like I think it's good,
Right.
and look, I mean, there certainly was a place for those things, and sometimes there still is, right? I mean, that's absolutely the truth. But
Yep.
in the 21st century, we're trying to put data to what it is we're producing, because otherwise we're not making parts as efficiently as possible, and we're leaving money on the table, honestly. I mean, and that's, I think, as much as we like to nerd out and get into kind of what's going on with prep and surface chemistry and all that, like at the end of the day, not knowing this stuff literally costs people money. And so that's what we're trying to do.
In this industry, that could be a significant amount,
Absolutely.
if a part doesn't bond or a part sticks. So, so I want to talk about some recent news before we get into the technology. So, I was reading about you guys, and I learned you were recently acquired by ClickBond, and you said this was around the first of the year. Tell us a little bit about how that came about.
Yeah. So, we were on a path to kind of upgrading our B-Connect platform, basically kind of bringing a couple specific features to it that we thought would bring a lot of value to our clients. And in some of the conversations with some of our, I'll just say, close partners out there around how we wanted to do this, our conversations with ClickBond, really, we started kind of recognizing jointly that, man, there really is a story here where we could potentially be better together, right? Kind of this 1 + 1 = 3 type of thing. And pretty quickly, like a plan formed in place where it was like, okay, look, ClickBond's got all these great bonding solutions out there. They're very reliable. They work well. They're interested in trying to help bring more value and more tooling for installation and repair to speed it up, right? Make it easier. And we provide that in spades, right? So we've got the handheld tools that allow technicians to install ClickBond products very quickly, very easily. And then on top of that, we're bringing a lot of the scientific background on what is happening with adhesion, right? And what are the best practices and the best methods, and what are some other ways that we can help ClickBond bring more bonded assembly, more bonded solutions to the aerospace industry. So it really kind of made sense. Now, we are joint, but we are a separate business still, right?
I see.
So we're still a small business unit. We've got our own thing going on. We don't just serve the aerospace industry. We're really in all industries to some degree. So, we're still doing our thing.
We were talking about before the show, you're not traveling as much. So I assume that allows you, because I would assume this partnership, or now that you're part of ClickBond, this allows you to kind of focus on the technology instead of being out there where you've got people with ClickBond out there meeting with.
Absolutely. I mean, there's a lot of really good collaboration there, right? I mean, it's kind of on both sides of the house, whether they're working with an engineering team to specify a particular bonding or fastener solution for a program, or whether they're supporting a client that's doing installs and they want a faster, easier way to do some installs. And so, like for me personally, it means I get to focus internally a bit more, and also on some of the bigger clients that we've got, some of the bigger programs where they're starting to institute our measurement tools. So that's been good. And so, and we've got some other tech in the pipeline that we're working on. I can't get into it yet today, but that's also a focus too.
Save that for a follow-up. Where is ClickBond? Where are they based out of?
Carson City. So they're in Carson City, Nevada.
Gotcha.
I think really since their beginning, really is Carson City, Nevada. So they've got a great facility out there. I think they got about 400 people on staff, and they've really got some cool solutions for. And I mean, obviously, this gets used a lot on their bonded fasteners, as well as like standoffs and studs and wire ties. They get used in composites all the time because you can eliminate drilling. You can eliminate putting holes in material. And in composites, that's a huge deal, right? Like, because if you put a hole in a piece of composite, you got to now make that composite thick to handle that stress location. And if you make it thick, well, guess what? It's no longer light. So you lose a lot of the benefits of using composites once you start mechanically fastening them.
Yeah. So walk us through, because I first learned about the company, I had the opportunity to sit in on, I think it was one of your technical people at one of the shows that I sat in on. I wish I could recall the name off the top of my head.
It might have been Joanne. We've got what we do for these conferences, like whether it's a CAMX or a SAMPE or especially these composites conferences, we are always trying to give a paper. We always try to give a technical talk.
No. I wish I could remember, but it was an incredible presentation, but laid out, the science behind water, water contact angle for surface readiness. So maybe for those who aren't as familiar, why don't you walk us through that process? Yeah.
So the basics really are, we're really just doing a quantified water break test. So if people are familiar with the water break test, this is something that's been done in painting forever. I mean, even, your certified Mercedes auto body shop is doing the water break test prior to painting a car. All right. And what it is we're doing is we're just measuring what a liquid does when it comes in contact with a surface. Right. And when you're doing, say, preparation or applying release, what you're doing in each one of those cases is you're really trying to modify the surface to be either really reactive, so it grabs onto your adhesive or grabs onto your paint really well through chemical reaction, or the opposite, right? Essentially non-reactive, hydrophobic. You want it to repel what you're going to put onto that surface. And so what we're doing is we are literally printing a tiny little purified water droplet onto the surface, and we're using a digital camera to measure how strongly attracted that water droplet is to the surface. And we can put a number to the angle that the water droplet makes with the surface, hence water contact angle. And so you can use this basically like a torque wrench, but for surface chemistry. You can define very specific ranges for what a good surface is, depending on your application. And there's rules of thumb around kind of what you want to do for a given surface system, but basically that's what it is. We're putting a number to what that droplet of water is doing on the surface, and that's going to mimic what your adhesive, your paint, your coating, or your release is going to do. Right? So it's a great little surrogate test and correlates directly. Those numbers will correlate directly to performance of that system when it goes together. So in a lot of cases, you get to reduce destructive testing, and in some cases, eliminate it completely, which can be a big benefit. Yeah.
And you mentioned coatings too. I mean, this is applicable to coating applications.
Really any solid surface that you're modifying in some way, right? Meaning you're applying a release to it so it doesn't stick. You're preparing it or cleaning it so it does stick. You're coating it for maybe corrosion protection, right, in the future. These are all surfaces where the reactivity or the surface energy of that substrate is key for the final performance of that assembly. And so, I mean, you can apply it all over the place.
So how does the technology validate things like sanding, abrasion? You got, solvent wiping, plasma treatment, flame treatment, even pill ply removal, which is, I'm sure a lot of people are familiar with, and other types of preparation processes there.
Yeah, so, every one of those preparation processes, some are doing very similar things, some are doing slightly different things, but the end goal is essentially the same. You're trying to create a surface that is reactive enough to accept your coating or adhesive in a reliable way. And you want to, a lot of times, getting to the ultimate or the best surface energy or cleanliness of the part, I'll typically use surface energy for composites, cleanliness for metals. Getting to the ultimate cleanliness level or surface energy level is not as important as making sure you've got the most consistent surface energy level, right? Yeah. Shift after shift, part after part. I group these prep methods basically into two categories: mechanical or physical preparation methods. This would be like abrasion. So think like grit blast, sanding, even laser ablation, peel ply. removal. You know, when you're removing peel ply, you're fracturing that top layer of resin. These are all physical. They're mechanical preparation methods. You're literally ripping molecules apart in a physical way, and now you have all these basically reactive sites on the surface. The other category is chemical surface preparation, and this is where you're literally changing or coating the top few molecular layers, and this would be like a plasma or a flame treatment, where you're actually you're literally putting reactive sites on the surface in the process of that treatment process. And so in all of these cases, even though the mechanism is a little bit different, you are increasing the amount of reactivity that is on that surface, sometimes by a very large factor, a factor of 10. And contact angles, because it is sensitive to the top couple molecular layers when you're doing something like this, when you do one of those processes, that contact angle is going to decrease. It's going to get more strongly attracted to the surface. And typically things like plasmas and flame treatment, we can actually get much lower contact angles than physical preparation methods like grit blast or a peel ply. Not to say they're always better. They're not always better. But you can kind of rank your preparation methods and what you're going to do based on a contact angle test. I mean, it's actually one of the things we'll do is you can really quickly understand, like, hey, is abrasive A better than abrasive B?
Sure.
Really quickly, you know, because not all 220 grit papers, as an example, are created equal, right? Or all, you know, Scotch-Brites, as an example.
Do you see between the two, is there in applications that you're working with, is it more chemical versus mechanical, or vice versa with
you know, I mean,
industries you're in?
Honestly, Jonathan, like, it is pretty industry dependent. So things like plasma and flame, they're great. I mean, we are big fans of a plasma treatment. We think it's a great kind of surface prep method. They're going to be geared more towards your industries that are automated. Yeah. Because whether it's a vacuum chamber or whether you got this thing on a jet, you got to have some high volume to justify the capital equipment cost to get that up and running. Yeah. You know, if it's a jet, it's on a robot, right? And now you got to like go over a large structure, as an example. It's clean, it's environmentally friendly, they're really reliable, like it's great, right? But it can't, for like the aerospace industry that's using a lot of composites, sometimes it can be cost prohibitive. You know, mechanical treatments like a grit blast. In fact, there was a Boeing engineer, I'm going to shout this guy out. Everybody needs to go read this dude's papers. Yeah. John Hartsmith. He has an incredible paper on grit blasting of composites, and he just nails it. I mean, grit blasting, there are some downsides around it being a little bit messy, and you got to change grit out and stuff, but man, it can be, when done appropriately, it can be an incredible surface prep for bonding of composites.
Grit blasting.
Grit blasting. Yeah, man. Yeah. I mean, it can be really, really good. Like, you can create, again, done appropriately. Yeah. You can create a very reactive, very clean composite surface with just the right amount of fractured resin to just get very, very good bonding to it. Now, look, you know, peel plies can do similar things like a grit blast, right? Or more manual abrasion. You can get to similar stages. So a lot of ways to skin a cat on this. You know, there's no like right answer. You know, the answer is it depends. I mean, it just depends what you're going to do, you know. You wouldn't be selling technical equipment unless you said it depends a lot. You know, that's something you got to say.
Well, it's like you said earlier, as long, you know, the point is, regardless of the process, you're trying to fracture that that surface.
Yeah, you got to fracture it, man. You got to break molecules. If you don't break the molecules apart or put new molecules on top, you're not going to have much to stick to. Right. Especially in composites, right? Composites are, you've got fiber bonded together by a polymer, right? Polymers, they're just long carbon chains. It's like spaghetti. Looks like spaghetti. There's just nothing there to work with. So you got to rip it apart, or put something new on top. I mean, those are kind of your two options.
So we had I'm curious. We had a guest on just recently on one of our episodes talking about. With L&L Products, actually talking about the thermoplastic adhesives that they're using now, and some of the benefits is that, you know, with thermoplastic adhesives, you're able to, these types of products. I mean, they're developing them to be able to bond not only to other thermoplastics but also to thermosets as well. Like, in some of the benefit is like, obviously these are, thermoplastics you can bond and debond. I'm just curious, do you guys have any work?
Well, and thermoplastics, I mean, you can actually injection mold them.
Yeah. Yep.
So
Exactly.
that's the other piece, right? Like, so the to me, the great promise of going to larger thermoplastic parts, and this is me thinking aerospace stuff, but the great promise is that you could essentially injection mold them and get the strength benefits and durability benefits of thermosets, right? Now, because they're not epoxy based, right? It really is it's a thermoplastic, and so what that means is you really have very little surface energy to bond to, and so typically for thermoplastics we would recommend a surface treatment. So like this is actually a really good point. Like, we're talking about mechanical treatments versus plasmas and flames. We would never recommend that somebody abrade a thermoplastic part. Like, if you abrade a thermoplastic part, you're not going to increase the surface energy of that material. You do want to do something like an adhesion promoter, a plasma, a flame.
Sure.
That's really the only thing that's going to actually increase your bond strength there.
Okay.
I think that, and obviously, adhesive technology is improving all the time, right? And so I am sure, though I don't know them myself or off the top of my head, I'm sure that companies like L&L have some adhesives that maybe don't need surface treatment all the time, right? Depending on what you're trying to do. But, typically to get the best, most reliable bond, that doing some kind of treatment or prep ahead of time is a good idea.
Yeah. We were talking earlier on the aerospace is a big part of your industry, your focus right now.
Definitely.
And I would say, is there any particular segment? I would say with drone technology, is that a particular area of interest for you all? Or
so let's just say, generally speaking, defense has picked up a lot. I think we're not the only. We're not the only guys.
Wonder why?
Right. We're not the only guys doing that, or kind of on the benefiting of that. Defense has picked up a lot. So drones, absolutely not in these. Let's just call them like larger drones. Ones that people are like putting some technology into and are designed to be reusable. That's a big area. Ordnance, so like missiles, generally speaking, is another area. I mean, what's actually been really interesting there is that since the increase in demand for missiles is actually really good for that industry as a whole, because historically those things have basically been made the same way for 50 years. There's been no change in how they've been putting those things together, to the point where even some of the materials that were being used, even some of the adhesives that were being used, are no longer available. And so what's happening is that with this increase, I think the latest report I was reading yesterday is like they're trying to get basically 8,000 more missiles produced per year by 2027. There's specific missiles that fall in that category. What that's doing is it means that the defense contractors can now update their manufacturing processes and the manufacturing lines. So they get more digital. They can update their prep methods. They can update the materials they're using as long as they're qualified. So it's kind of like a little bit of a renaissance in that space, because for the first time in a long time, they're able to update what they've been doing. So it's cool, and
that is great.
It's opportunity for us, right?
Yeah, absolutely. That brings you into the picture.
100%, because these engineers who we've talked to for a long time are finally coming back, and they're saying, "Oh, yes, I have a reason, and I have a need. Now I can implement this. I've been wanting to implement this for 5 years. Let's go," which is cool. So that's a good thing.
So that's really, I guess, sparked, I guess, that particular sector for you all.
Totally. I mean, at this point, Jonathan, we're not just providing hardware like measurement tools. We're handing guys and the entire composite surface preparation, control plan, and workflow.
Hmm.
So like one of the conversations we'll have very early on with an engineering team is like, hey, look, here's our composite bond spec,
Yeah.
Brighton's composite bond spec. Here's how we would treat this if we were you making your part.
Sure.
And these things are templates, right? You tweak and tune based on your situation, but we're very deeply involved with engineering teams to help them set these things up so they get the first pass yield, right? When they launch it, this thing is working. And it's been interesting because like our hardware provides that data, but because we've learned so much over the last decade getting this data, it means we know a lot about the overall process.
Yeah. What is the, when people ask you, what is the best way to calculate ROI? On these projects? Because you were talking, there's some industries that, their volume is huge. Some are not so much, but then they're
but the part's expensive.
The parts are super expensive.
So the cost of failure is high. I mean, I'll say,
DoD projects, you don't want to fail there.
No, because absolutely not. Because if you've got, and in fact, they'll typically not try to scrap a part. They'll rework it as much as they possibly can. But guess what? In composites, you can only sand so much.
That's right. Yeah.
Right. At some point you've sanded too much, and that part's wrecked. So
that's right.
We want to avoid that. So like ROI calculation, it's totally dependent on where you're at in the program lifecycle. Like, are you early, or like, are you early and you're speccing things in to get maximum quality and best efficiency? Or are you late in the program? You've been making something for a while, but you've got failure and you're trying to reduce either the rework or the scrap rate. The ROI calculations are different in those two instances.
Yeah.
But it's always any piece of QC. Doesn't matter what kind of QC it is. It's essentially insurance. Really, I mean, you're buying down the risk of something going wrong, and you've got to make that calculation, right? For like, okay, I'm going to spend $100,000 because I guess what now I get to increase the life of my grit, and I don't have to recycle it every 3 weeks. I can recycle it every 10 weeks, and the ROI is paid for in 2 months, right? As an example, so. It totally depends. Sometimes it's continuous improvement. Sometimes you're early in the program and you want to buy down the risk on the whole program. Sometimes you're saying, man, I'm scrapping 3 parts a month and I want to eliminate that.
Yeah.
The cost of scrap is X.
As you said earlier, when you're getting, these engineers are reaching out to you now and they're like, hey, we've got the opportunity. Is this something that you're visiting them, you're going out there, you're bringing the technology, you're running? I mean, how does that, where does that go from there?
Typically our interactions with clients, and we call them clients on purpose because remember, we've got this kind of consulting background. So even though we're out here selling hardware, we're selling equipment, it's not a transactional sale, right? We're getting embedded as deeply as they want us to be embedded, right? Sometimes we are a direct extension of the materials and process team, just with a niche on bonding.
You become part of the research team, maybe.
Exactly. We become part of that team, and so depending on what that relationship looks like, sometimes it's just a matter of through our virtual video room, doing some laboratory studies in real time on live stream. Right. Sometimes it means we're getting on a plane and we're going to go do some work in their lab. I mean, it kind of depends on the scenario, but I'll say generally speaking, what's been really, I've been doing this now for 13 years and I started with the business when we were 4 people. There's a huge difference in just the, I'll say, understanding and acceptance in the general composites market of this kind of test. It is becoming more and more the standard. Whereas 12 years ago, we were out there knocking on every door saying, hey, did you know about this? Did you know you could do this? Did you have any idea that this was possible? And now that's much less the case.
Your dad
now people are coming
this,
out
right?
saying, okay, we've been looking at this for a while. We know it's the thing to do. Like now it's time. We're going to do it.
Yeah. It started with your dad, didn't it? Right?
Yeah, it did. It did. Yeah. My dad, he invented the technology with him and a couple friends. And
I mean, how did that, I'm always curious, what was his background in?
Yeah, so he's a PhD material scientist.
Okay. All right.
He got his PhD at the University of Cincinnati,
Yep.
worked at Dow Chemical in
Wow.
Michigan
Okay.
for a couple of years, and then
Yeah.
worked at a plastics compounder, basically one of the first guys kind of really doing recycled plastics in Kentucky, in northern Kentucky after that. And then
Sure.
he ended up getting into a small business innovation research program with his old advisor from UC, this guy,
Yeah.
Dr. Jim Borio. And then they got involved in the Composites Affordability Initiative, which was a program in the late 90s, early 2000s, the CAI program.
Yeah.
And they were a subcontractor to Boeing. And they looked at that whole program. I mean, they were looking at ways to make composites more used in the aerospace industry. And the big thing there was bonding, because no one wanted to bond up a whole wing. I mean, they were scared of it. There was no NDI method to do that. So they looked at how do we make bonding more reliable.
Yeah.
And the whole thing was wetting. Like, okay, we did all kinds of different range finding to figure out, hey, like, what's the best way to do this? And then out of that work, he got funded by Air Force Research Labs to build a handheld tool to put in the hands of a mechanic. And that was a new concept, right? I mean, that was definitely a new thing. So that's kind of where it all came out of, man. Honestly, it was an SBIR program. Boeing had their hands in it early. Air Force Research Labs had their hands in it early. Lockheed, the F-35 program was really the first commercial adopter of this method. And we learned so much with them. I mean, the good and the bad. I mean, it was amazing. When you take a measurement technology like this, it's measuring things that you have not measured before. And then you put it into the factory with real techs, real surfaces, things that are covered in dirt and oil. And I mean, it is a trial by fire. Yeah. Just learning, okay, what's this thing really telling us,
How big's the team now up there in Cincinnati?
We're about 50 people.
Wow.
Now
Nice.
we're about 50 people. We've got basically our consulting group that does our laboratory work, and I'll say kind of IR&D. We got an engineering team. Everything is, in terms of hardware, everything is made in Ohio. We've got a supplier that basically does our sub-assemblies. We get them in-house, and we do kind of all of our final assembly, calibration, service, turnaround. All that happens in Cincinnati.
Outside of aerospace, what would you say would be maybe the next 2 or 3 industries that you're heavily involved with right now?
Yeah, it kind of follows adhesive use. So automotive, I'd say, is a pretty close number 2. We do a fair amount in automotive. If you think about just think about a car and all of the different material systems and all of the systems that require consistent surfaces for success. So bonding windshields, bonding sunroofs, painting bumpers, cleaning engine components so that they seal well. I mean, there's just cameras. You got all these cameras in the car. These are all things that our technology is getting used on today. So I mean, I would say automotive is a close number 2, and we're in Ohio. So we're right on the 75 corridor.
That's right.
So it's kind of
Ohio,
it's
Michigan.
unavoidable.
I mean, it's
a little bit unavoidable. So.
Good place to be right now.
Yeah, absolutely.
Lucas, this has been great. I wish we had more time. Time flies, man. We were saying earlier, like time flies. There's other stuff that I could talk to you about, but we'll save that for another follow-up.
Sounds good.
Will you guys be at CAMX?
Yes.
Any of your team going to be at CAMX?
We'll be. Yep.
Okay.
Yes, we'll have a booth at CAMX. We are going to be at Farnborough at the Farnborough Air Show.
Okay.
Next week, we're going to be in the ClickBond booth. We got a whole demo set up. So
nice.
We're definitely really excited for that. That's a big one. But yeah, we're going to be at CAMX.
Will you and ClickBond be together at CAMX?
Yeah, we will be. Yeah, we're going to be in the same booth. We've got our own area in the ClickBond booth, but yeah, we're in the same booth. Well,
I'll have to send you an invite for doing, maybe a live interview at the show. Yeah. We'll be streaming those during that week. So
awesome.
Hopefully that'll give us an opportunity to bring yourself and maybe someone from ClickBond over, and we can talk.
That'd be great. So you're going to be at Farnborough?
Oh, no. I'll be at CAMX.
Oh, yeah, definitely. CAMX. No problem. We can definitely do CAMX. Yeah, we can totally do that.
Yep. Yeah, that'll be the next one. And then you guys are typically at the Sampi show too, right?
Yes. Yep. Yeah. We're typically at Sampi. Yep. Those two, on the composites front, those are really the two that we frequent.
Absolutely. Very good.
Great.
Lucas, always fun, man, to catch up and have a conversation. Can you continue to wish you guys the best moving forward? The future looks bright, I know. You guys are super busy, and look forward to catching up again soon. Hope you have a great weekend.
Hey, thanks, Jonathan. Appreciate it.
Yep. Hang tight. Let's
All right.
see.